The project consists in the refurbishment of an abandoned school situated in a degraded neighbourhood in the outskirts of Naples. The school building has been assigned by the Municipality of Naples to the association Maestri di Strada, and the usage agreement stipulates that the association should provide an adequate energy renovation and revamping of the building. Maestri di Strada is a non-profit association of professional educators who have the mission to reduce early school dropouts and to facilitate the insertion into society of young people at risk of social exclusion and poverty. Currently, the property is not functioning because of significant damage to its structure, mostly due to water infiltration through roofs and terraces incapable of draining rainwater properly. The building is completely flooded and in an evident state of abandonment. In 2019, Maestri di Strada signed an agreement with BIM, the Italian chapter of Building Smart International. A few members of BIM volunteered to participate in the renovation of the school and offered to model the existing building for different BIM uses. This modelling project started from a master thesis on energy requalification, and it has now turned into a pilot project for future energy renovations and upgradings of structural security for thousands of schools in need in Italy. This school is, in fact, an inspiring case study for the Ministry of Education and the Ministry for Southern Italy, who went to meet Maestri di Strada to learn about the innovative technologies applied, and they are evaluating the possibility to implement them in a large scale of renovation works. A difficulty to overcome was the necessity to redraw all of the plans, elevations and cross-sections of the school that got burnt in a suspected arson. The first contribution to the modelling was given by Tamburi SRL that developed the point clouds of the building and the annexed area through a scan. ACA Software has provided the common data environment to allow the different professionals to collaborate on the same platform. Two young architects from the University of Naples Federico II entered the information regarding the different items needed for the building. However, it was not possible to insert value for the thermal bridges, as it is the result of analysis of the sources of dispersion and problems of condensation that cause mould and unhealthy environments. A cause of the lack of the documentation, it was not known the structural solidity of the building, which is located in an area at high seismic risk. It was hence decided that the ETS SRL would carry out an inspection to identify all the critical points through the IFC model that were then examined and shared on the ACCA CDE. The result of the inspection confirmed the use of prefabricated reinforced concrete elements and the presence of pillars made on site for the assembly. This verification was helpful also to confirm the possibility of installing photovoltaic panels that ANEA donated to the school to produce its own electricity. At this point, it was possible to compare results among different softwares. The study focused on the problems of exporting the Graphisoft IFC file on 3 different energy simulation softwares. The best performing software resulted to be Thermalog. However, it only reads the DWG obtained from the BIM model. Thermos, on the other hand, reads the IFC directly, while Cypertherm showed problems reading IFC 2 and 3, while it seems to have no problems with IFC 4. The main import problems in the energy software concerned the curtain wall elements, skylights, pillars and a pitched roof. The energy analysis led to the identification of an E energy class, leaving a large space for improvement. IBIMI and Maestri di Strada organised a workshop in order to determine the requirements for a Class A building, also thanks to a smart usage of BIM technologies that would also ensure economic sustainability. The initial situation consists in an excessive heat dispersion during winter and high heat and humidity levels during summer. It was assessed by the different working groups that the use of photovoltaics integrated with heat pumps could meet the energy needs. The prerequisite is an improvement in the insulation of the roof and the replacement of the fixtures of windows that cover most of the external walls. The use of BIM for maintenance, BIM 7D, entails that all the technologies identified for energy requalification, once installed, are represented in the BIM model with all their technical data sheets. This permits to define a preventative maintenance plan as well as to intervene promptly in case of anomalies. Thanks to the existing modelling, during the workshop, educators of Maestri di Strada identified the uses of main working areas, which allowed to make simulations and evaluate the optimal energy measures for the different parts of the school, according to their HAVC needs. Global Power Service carried out a market investigation and chose a thermoacoustic insulating panel in wood fibre to be installed on an inclined reinforced sheet to guarantee good insulation during summer and stop the infiltrations of water. A truly innovative use of BIM for Maestri di Strada will consist in using the BIM model as a tool for self-construction training. For this reason, it is useful to collect in a single common data environment all of the studies undertaken and decisions made, both on site and remotely. This report will allow to develop a course for the architects and engineers who will be able to see what has been done both in the virtual and in the real environment. The establishment of a welcoming multi-purpose centre in the middle of such a problematic neighbourhood of Naples will hopefully motivate many more local students to attend the school. Schools and classrooms will soon be available to visit online, which will contribute to the promotion of the activities and to attract more interest. This would subtract many of them from local organised crime, which is the ultimate objective of Maestri di Strada.